Welcome to the deep dive. We sift through the latest articles and research, basically pulling out the key insights so you can get informed fast. Today we're diving into, well, just an incredible story, the surprising journey of Homo sapiens. How we ended up being the only human species around, because for most of our history, we definitely weren't alone.
Exactly. And our mission here is to really unpack the insights from the sources you've sent over. We'll focus on those huge revolutions that shaped us, our, biological family tree, and the unique traits that led to us being, well, us. Hopefully it gets you thinking a bit differently about what it even means to be human.
Okay, let's set the stage. And I mean the really big stage. The sources start us off pretty much at the beginning. Big Bang, 13.5 billion years ago. Matter, energy, time, space, physics, basically.
Right. Then maybe 300,000 years later, give or take, matter and energy start clumping together.
Yeah.
You get atoms, then molecules. That's where chemistry comes in. And then fast forward a huge amount, about 3.8 billion years ago, right here on Earth. Some of those molecules get really complex. They form these intricate structures, organisms. And that's biology stepping up.
Yeah, and then really just a blink in cosmic time, maybe 70,000 years ago, organisms from our species, Homo sapiens, start forming even more complex structures, cultures.
And that development, human cultures.
Yeah,
That's what we call history.
precisely.
So within that history, the sources you shared highlight three really pivotal moments, three big revelations. First, the cognitive revolution kicked things off around 70,000 years ago.
Then came the agricultural revolution, speeding everything up about 12,000 years ago.
And finally, the scientific revolution, only 500 years ago, which is kind of mind-blowing. And some analyses suggest it could even be leading to something totally new, maybe even the end of history as we know it.
It's a big thought, but for this deep dive, we're really zeroing in on the very beginning of that journey, that initial phase, because understanding our origins, that really sets the stage for everything else that follows, you know? Absolutely. So let's go back before history then.
Okay, it's crucial to grasp that humans were around for a long time before history started. We're talking animals that were clearly human appearing about 2.5 million years ago. But, and this is the kicker from the sources, for ages, for millions of years, they were just unremarkable animals. They had no more impact on their environment than gorillas, fireflies, or jellyfish.
Wow. That really puts it in perspective, just another creature.
Exactly.
The sources paint this picture 2 million years ago in East Africa. And it sounds so familiar, right? Anxious mothers, kids playing, moody teenagers, guys puffing their chests out.
Right, all behaviors we'd recognize.
But the point is, chimpanzees did that too. Baboons, elephants.
Yeah.
There was nothing really special about us then.
Absolutely, and nobody, least of all them, had the slightest clue about, moon landings or iPhones or any of it.
So how did we get from there to here? Let's talk biology, our place in the family tree.
Okay, yeah, a quick refresher might help. Biologists classify things, right? So species. Animals that can breed and have fertile kids, think bulldogs and spaniels, same species, but horses and donkeys. They make mules, but mules are sterile. Different species.
Got it.
Then you group related species into a genus, like Panthera that includes lions, tigers, leopards, jaguars, all big cats, common ancestor. Our genus is Homo, meaning man.
Okay.
And then you group genera into families, like the cat family, the dog family, the elephant family. All cats, from your house cat to a lion, share a common ancestor way back, maybe 25 million years ago.
Right. So where do we fit?
Well, this is what the sources call a kind of banal fact.
Right.
That was once a big secret. Homo sapiens, us, we belong to the great apes family.
Alongside chimpanzees, gorillas, orangutans.
Exactly. And our closest living relatives, chimps.
Wow.
And get this detail from the material. Just 6 million years ago, there was this one female ape. She had 2 daughters. What became the ancestor of all chimps?
Yeah.
The other, she's our great-great-great-grandmother.
That's incredible. So thinking about chimps and gorillas, what jumps out at you? What makes us different? Or maybe what made us seem not so different back then?
Well, one thing that jumps out, and that sources stress this, is how we usually picture evolution. Like a straight line, right? One species neatly turning into the next, leading straight to us.
Yeah, that classic image, the ape gradually standing taller.
Right. But the reality, the evidence shows it wasn't like that at all. It was much messier, much more diverse.
Okay.
Because for a huge chunk of time, from about 2 million years ago right up until maybe 10,000 years ago, the world wasn't just home to us. It was home at one and the same time to several human species.
Wait, several at the same time?
Yeah. Our current situation, being the only human species left, That's actually, as the sources say, peculiar and perhaps incriminating.
Incriminating. Wow. Okay, so who are these other humans? Our siblings?
Well, there was quite a family. You had Homo rudolfensis and Homo ergaster in East Africa early on. Then Homo erectus spread out into East Asia. And they were incredibly successful, hung around for almost 2 million years, the most durable human species ever.
2 million years? That's staggering.
Isn't it? Then, maybe more familiar, Homo neanderthalensis, the Neanderthals, Europe, Western Asia, bulkier than us, more muscular, adapted to the cold. And the material notes, they actually had larger brains than sapiens.
Larger brains. Interesting. Okay, who else?
We had Homo silensis down in Java, suited for the tropics. And then this really fascinating one on the Indonesian island of Flores, Homo floresiensis.
Ah, the hobbits.
Exactly. Tiny things, about a meter tall, 25 kilos. But they weren't simple creatures. They made stone tools, hunted dwarf elephants on that island.
Incredible. Any others?
Yep. Relatively recently discovered, too, in 2010, from just a fossil finger bone found in a cave in Siberia, Homo denisova, the Denisovans.
Just from a finger bone. Wow.
Amazing what they can do with ancient DNA now. So the picture that emerges isn't a line, it's a bush. Massive humans, tiny humans, hunters, gatherers, some spread across continents, others isolated on islands. But all of them, the sources emphasize, were human, members of the genus Homo.
That completely changes the picture. So we sapiens weren't the inevitable outcome. We were just one branch among many.
Exactly. For a very long time.
Okay, so let's dig into what makes humans, well, human. Starting with that big brain you mentioned. Neanderthals had bigger ones, but ours are still huge compared to other animals, right?
Extraordinarily large brains, as the material puts it. Sapiens averaged 1,200 to 1,400 cubic centimeters. Compared to body size, it's enormous.
But it comes at a price. The sources call it a jumbo drain.
It really is. Think about it. The brain is maybe 2–3% of your body weight, but it uses 25% of your energy when you're just sitting around.
25%, just for the brain.
Yep. Compare that to other apes, their brains use about 8%. So early humans paid a price. Two big ways, according to the research. One, more time needed just to find food to fuel that hungry brain. Two, muscle atrophy. Energy got diverted.
What the source says, energy from biceps to neurons.
Exactly. Which wasn't an obvious advantage out on the savannah back then. A chimp couldn't win an argument with a sapiens, sure, but...
The ape can rip the man apart like a rag doll.
Yeah, I saw that quote. So why the big brain then for 2 million years before it gave us, major technological edges?
That's a huge question. We still don't really know the full answer. It wasn't immediately obvious why it was worth the cost.
Okay, another key human thing. Walking upright. Bipedalism.
Right. Obvious benefits. See further over the grass, spot predators or prey.
And crucially, it frees up your hands.
Yes. For carrying things, for making tools, for intricate tasks. We see tool evidence going back 2.5 million years. That hand dexterity is vital.
But downsides too, right? The sources mention backaches, stiff necks. Definitely. Our skeleton basically evolved for walking on all fours. Standing up put a lot of strain on it, especially supporting that increasingly large head.
And women paid an extra price, didn't they? Something about childbirth.
A really significant price. Walking upright requires narrower hips. But at the same time, babies' heads were getting bigger because of those growing brains.
Oh, that's not a good combination.
No. It made childbirth incredibly dangerous for human females. Far more so than for other mammals. Natural selection actually favored earlier births.
So babies are born less developed.
Exactly. Prematurely, in a way. Think about a foal. It can trot soon after birth. A kitten is independent relatively quickly. Human babies, utterly helpless for years, dependent for food, protection, education.
But that vulnerability,
Yeah.
It had a social payoff.
A massive one. This helplessness is a key driver, the sources argue, behind our amazing social abilities. A lone mother couldn't possibly manage foraging and childcare alone. You needed help, family, neighbors, the whole group. It takes a tribe to raise a human.
Ah, so it pushes towards cooperation, strong social bonds.
Precisely. It favored those who could cooperate and form strong ties. And being born so underdeveloped, so malleable, the sources compare it to molten glass from a furnace. It means we can be educated and socialized to an incredible extent, far more than any other animal.
But which explains our cultural diversity. Christian, Buddhist, capitalist, socialist.
Exactly. That long period of dependency allows for immense learning and cultural shaping.
Okay, so we've got big brains, upright walking, complex social lives. But where did we sit in the grand scheme of things, food chain-wise?
Well, for most of those millions of years, we were distinctly average. middle of the food chain stuff.
Not the mighty hunters we imagine.
Not at all initially. The sources are clear. Early humans hunted small creatures, gathered plants, insects, nuts. And crucially, they were hunted by larger predators. They lived in constant fear of lions, saber-toothed cats.
And those early stone tools. Not for bringing down mammoths.
More likely for cracking open bones after the real predators had finished. Getting at the marrow, scavenging, waiting for the lions and hyenas to leave.
So we were scavengers first. When did that change? When did we start climbing the ladder?
It was a slow climb at first. Maybe around 400,000 years ago, some human species started hunting large game more regularly. But the really big jump, the absolute top, that seems to happen much later, really accelerating in the last 100,000 years or so, particularly with the rise of Homo sapiens.
And that leap, the sources argue, was problematic, too fast.
Exactly. Think about lions or sharks. They evolved into apex predators over millions of years. The whole ecosystem adapted alongside them. Checks and balances developed. Humans, we jumped from the middle to the top incredibly quickly. The ecosystem had no time to adjust. And, maybe more importantly, we didn't have time to adjust psychologically.
The source uses that analogy, more like a banana republic dictator.
Yeah. We were underdogs for so long. Suddenly finding ourselves at the top, we're still filled with fears and anxieties over our position, which, the argument goes, makes us doubly cruel and dangerous. Many historical disasters, wars, ecological catastrophes, maybe they stem from this over-hasty jump, still trying to secure our position maybe.
That's a really sobering thought. Okay, so what allowed that jump? What were the key innovations? Fire seems like a big one.
Oh, huge. The domestication of fire was revolutionary. Some used maybe 800,000 years ago, but the sources suggest daily use by various human species by around 300,000 years ago.
And it gave us light, warmth, protection from those predators we were talking about.
Absolutely. And a way to change landscapes, burn down forests to create grasslands, attracting game. A powerful tool.
But the sources really emphasize cooking.
Yes, possibly the best thing fire did for us. Suddenly, things you couldn't digest easily, like wheat, rice, potatoes, they become staples of our diet once cooked.
So those germs and parasites too, right?
Big advantage. And it dramatically cuts down on eating time. Chimps spend like 5 hours a day just chewing raw food. Humans eating cooked food, maybe 1 hour.
That frees up a lot of time
Yeah.
and energy.
Exactly. And here's a fascinating link some scholars propose in the material. Cooking leads to shorter intestines. Digestion becomes easier, requires less energy. And where does that saved energy go? Potentially towards fueling those energy-hungry jumbo brains of Neanderthals and sapiens.
Wow. So cooking might have directly enabled bigger brains.
It's a compelling theory. Fire and cooking, the sources argue, created the first real gap between humans and other animals.
How so?
Well, an eagle's power is limited by its body, its wingspan, its talons. But humans, with fire, gained control over this external force. Obedient and potentially limitless, as the source says, one person with a torch could destroy a whole forest. The power wasn't limited by the human body anymore. A sign of things to come.
A profound shift. Okay, so we have fire, potentially bigger brains, partly thanks to cooking. And then sapiens arrives on the scene.
Right. By about 150,000 years ago, Homo sapiens are in East Africa. They look pretty much like us. Skulls are big, teeth and jaws smaller, likely thanks to cooked food.
Still marginal creatures globally, though.
At that point, yes. But then, around 70,000 years ago, something changes. Sapiens start spreading out of Africa, into the Arabian Peninsula, and then, boom, across Eurasia, relatively quickly.
And Eurasia wasn't empty. Those other human species were already there. Neanderthals, Erectus, Denisovans.
Exactly. Which leads to the big question, what happened when sapiens met them?
The sources lay out two main theories, right? Interbreeding versus replacement.
Correct. The interbreeding theory is kind of the make love not war scenario. Sapiens spread, met other humans like Neanderthals, found them attractive, and mingled. So modern Eurasians, according to this theory, wouldn't be pure sapiens, but a mix. Part sapiens, part Neanderthal, maybe part Denisovan or Erectus.
Okay, that's one story. What's the other?
The replacement theory. This one suggests incompatibility. Different looks, different smells, different habits. Maybe even genetic barriers making fertile offspring impossible or very rare. In this view, sapiens arrived and the other human populations just died out. Replaced without any significant mixing, maybe outcompeted, maybe killed off. It implies we're all pure sapiens descended from that original African population.
So love and merging or incompatibility and potentially genocide, those are pretty different outcomes.
Very different. And the sources point out this isn't just ancient history. It had, and still has, political implications.
How so?
Well, if the interbreeding theory was totally correct, suggesting significant mixing, it could be interpreted, or misused, to argue for deep, ancient genetic differences between modern human populations. The material calls it political dynamite because of the potential links to racism.
Right. Whereas the replacement theory suggests we're all much more closely related, genetically very similar under the skin.
Exactly. For a long time, replacement was the more widely accepted view, partly for those reasons perhaps, and because the physical evidence for mixing was scarce.
But then, genetics happen. Big time.
Oh yeah. 2010 was the watershed year. They mapped the Neanderthal genome.
And the results were?
Stunning.
Huh?
They stunned the scientific community, as the sources say. It turns out that modern people of European and Middle Eastern descent have between 1 and 4% Neanderthal DNA.
Whoa. So there was interbreeding?
There was some. Not a total merger, but definitely some successful breeding. And it didn't stop there.
Yeah.
A few months later, they sequenced DNA from that Denisovan finger bone and found that modern Melanesians and Aboriginal Australians carry up to 6% Denisovan DNA.
6%. That's
Yeah.
significant.
It is. So the picture is more complex. Not full replacement, not full merger. The sources suggest these groups were right on the edge of biological compatibility. Almost, but not quite, entirely separate species around 50,000 years ago.
Close enough that occasionally, very occasionally, they could produce fertile children together.
Exactly. Which is, as the material notes, unsettling and perhaps thrilling.
Yeah.
The idea that our direct ancestors could and did have children with individuals from what we now consider a different species.
Okay, so if it wasn't a complete merger, and sapiens didn't just absorb everyone, why did all the others vanish? If we were interbreeding a bit, why didn't they stick around?
Two main possibilities are put forward. One is competition. Maybe sapiens were just slightly better at hunting, gathering, adapting, maybe had better technology, better social organization. Over time, even a small advantage could lead to the others dwindling.
Outcompeted for resources. Makes sense.
The other possibility is darker. Violence. Genocide.
The incriminating part you mentioned earlier.
Yeah. This source puts it bluntly, tolerance is not a sapiens trademark. If we look at human history, how sapiens have treated other sapiens over minor differences.
Religion, skin color, language.
Exactly. It's not a huge leap to imagine our ancestors encountering beings who were clearly human, but different, and reacting with fear, hatred, and violence. It might have been, the source speculates, the first and most significant ethnic cleansing campaign in history.
That's chilling. And the timeline fits, doesn't it? As sapiens spread, the others disappeared.
Pretty much. Homo soloensis in Java, gone around 50,000 years ago. Denisovans shortly after. Neanderthals hold out until about 30,000 years ago. And the little Homo floresiensis on their island, they lasted until about 12,000 years ago.
And then? Just us. The last human species standing.
The last ones.
That makes you wonder, doesn't it? What if it hadn't turned out that way? What if Neanderthals or Denisovans had survived alongside us?
What kind of world would that be? The sources pose this question. Different cultures, societies, maybe different religions entirely. How would our politics, our philosophies have developed?
Would the U.S. Declaration of Independence say all members of the genus Homo are created equal? Or just sapiens?
It's impossible to know, but fascinating to think about. Maybe, the sources suggest, our ancestors wiped them out precisely because they were so similar. Too familiar to ignore, but too different to tolerate.
And wiping them out allowed us to see ourselves as unique, as the pinnacle.
Perhaps. It certainly made it easier to draw a hard line between us and them being the entire rest of the animal kingdom.
So what was sapiens' secret weapon? What allowed us to spread so fast, outcompete or eliminate everyone else, and conquer the planet?
The most likely answer, the one the sources point to again and again, our unique language.
Language.
Not just alarm calls like other animals, but complex, flexible language. The ability to talk about things that aren't right here, right now. To plan complex actions. To create myths, laws, gods. To cooperate flexibly in large numbers.
The very thing allowing us to have this conversation right now.
Exactly. That seems to be the key differentiator. The spark of the cognitive revolution.
Incredible.
So, thinking about this whole story, our rapid jump to the top, our history with other human species, our tendency towards intolerance even within our own species. It leaves us with a final thought, doesn't it? What does this history imply about our future impact on the planet, and maybe even on ourselves, especially as our technological power continues to grow? Something for you, the listener, to consider.
Definitely a lot to think about there. Thank you for joining us on this deep dive into the The truly amazing and sometimes unsettling story of becoming human. Keep exploring.